All right, welcome to The Explainer. Today we're diving deep into the Cisco Umbrella Secure Web Gateway. We're going to break down what it is, how its policy engine actually thinks, and then, of course, how you can configure it effectively. So, let's get right into it. So here's what we've got on tap. We'll start with the big picture, what the Umbrella SWG is all about. Then we'll zoom in on its core features. After that, and this is the really important part, we'll get into the logic, how it makes decisions. And finally, we'll wrap it all up with how to actually configure it, along with some best practices.
Okay, first things first, let's start with the absolute fundamentals. What exactly is a secure web gateway? And, where does it fit into your security stack?
So, at its heart, the Umbrella SWG is a cloud-native security service. So you can forget about having a physical box on-prem. Instead, all the devices on your network, and it doesn't matter if they're in the office or working from a coffee shop, they all connect to the Umbrella cloud. You can do this a few ways, right? Through an IPsec tunnel, using the AnyConnect client, or even with simple pack files. But here's the main takeaway. All of their internet traffic gets funneled through this one central point for inspection and, of course, for enforcing your policies.
Okay, so what does it actually do? The best way to think about it is like a really, really smart checkpoint for all your web traffic. Yeah, it logs every single request, which gives you incredible visibility, but its real power, that's in being your first line of defense. It's actively blocking malware, it's enforcing your company's acceptable use policies. Basically, it's combining what used to be a whole bunch of different security tools all into one single cloud service.
All right, so we've got the 30,000-foot view. Now let's zoom in a bit and look at the specific features that make this thing so powerful. Okay, check out these key capabilities. We're talking about really granular file controls, selective traffic decryption, and we'll get into why that's important, application blocking, and even some seriously advanced malware sandboxing. Every single one of these is a critical tool you'll want in your security toolbox.
Today, almost all web traffic is encrypted, right? SSL, HTTPS, it's everywhere. And that's great for privacy, but it's a real headache for security because, well, attackers love to hide malware inside that encrypted stream. So this is where SSL decryption becomes absolutely essential. Umbrella can crack open that traffic and inspect it, but here's the really cool part. It can be selective. You can tell it, hey, don't touch sensitive categories like personal finance or healthcare. And that is just crucial for striking that perfect balance between security and user privacy.
So let me ask you a question. Do you know every single cloud app your users are hitting up during the day? I mean, honestly, probably not. That's the whole shadow IT problem, and man, it's a massive risk. Umbrella really helps you get a grip on this. It discovers and reports on all those apps, gives you risk data on them, and most importantly, it lets you either block the unapproved ones flat out or create really specific controls for the ones you do decide to allow.
But what about those brand new zero-day threats? The stuff that's never been seen before? Well, for any suspicious files that don't match a known malware signature, Umbrella sends them off to the Threat Grid sandbox. Think of it like a digital bomb squad. The file is detonated and analyzed in a completely safe, isolated environment. And if it starts doing anything shady, you get a retrospective alert. That means you can respond to the threat even if it's slipped past the initial defenses. And believe me, the list just keeps going. You get full, detailed URL logging. We're talking the whole URL, not just the domain. It's backed by Cisco Talos, which is one of the biggest threat intelligence teams on the planet. You can block file downloads by type, so no more random executables. And with remote browser isolation. Oh, this is cool. You can actually render risky websites in a secure remote container. The bad stuff never even touches the end user's device.
Okay, now I need you to lean in for this next section, because this is absolutely critical. We've seen what the SWG can do, but now we need to understand how it decides what to do. This is the brain of the operation, the logic engine that drives literally every single policy decision.
Okay, so here's how the logic works. It's actually pretty straightforward when you break it down. When a web request hits Umbrella, it starts looking through your rule sets from the top down, highest priority first. For each one, it asks a really simple question. Does the person or the device making this request match an identity I know about in this rule set? If the answer is yes, boom, it applies that rule set and stops right there. If it's a no, it just moves on to the next rule set down the list until it gets a match.
Now, here's where it gets interesting. A single request could actually have a bunch of identities tied to it, right? You've got the user who's part of a group, who's on a specific laptop, which is on a specific network. So how does Umbrella decide? Well, it has a very clear pecking order. An Active Directory user is the most specific, so it always wins. That takes top priority. Then comes their group, then the device itself, the roaming computer, and finally the network or tunnel.
And that brings us to stage 2 of the logic. So once Umbrella has found a matching rule set, it then dives inside that rule set, and it does the same thing. It evaluates the rules from top to bottom. It's looking for the very first rule where both the identity and the destination match the request. The second it finds one, it applies that rule's action, whether that's allow, block, warn, or isolate. And that's it. The evaluation process stops cold.
All right, so that's the theory. Enough of the how it works. Let's get into the how you do it. We're going to walk through the practical, hands-on steps of actually configuring these policies.
Now, before you even think about creating your first rule, you've got to do some prep work. It's super important. First, you need to make sure all your identities are defined in Umbrella. That's your networks, your users, your roaming computers, all of it. Second, and listen, this one is non-negotiable. If you want to do HTTPS inspection, you must deploy the Umbrella root certificate to all your user browsers. And finally, go ahead and pre-build any destination lists and custom block pages you know you're going to need.
So when you get to the main configuration screen for a rule set, this is where you bring it all together. You'll give it a name, obviously. But then, and this is the key part, you assign the specific identities that this rule set applies to. This is also where you'll flip the switches for the global settings for this rule set, things like turning on HTTPS inspection or file analysis.
Okay, so once that rule set is defined, now the fun begins. You can start adding your rules. And for any combination of an identity and a destination, you get to choose from 4 really powerful actions. You can allow it, no problem. You can warn the user before they continue. You can block it completely. Or, for maximum protection, you can isolate that entire session in a secure remote browser.
Okay, so we know how to build the policies now. Let's talk about how to build them the right way and how to make sure they're working exactly like you think they are.
Now this next idea, this is absolutely fundamental to getting this right. A lot of people's first instinct is to just dump everyone into one big, broad default rule set. The best practice is to actually flip that logic on its head. Make your default rule set, that's the one at the very bottom that catches everything else, make that one your most restrictive. Then you build more permissive rule sets on top of it, and you treat them like specific, targeted exceptions for different groups.
And here are a few more pro tips for you. First, layer your rule sets based on context. For example, have a stricter policy for when users are on the corporate network versus when they're roaming. Second, use those dynamic, top-level groups so new devices automatically get the right policy. Also, try to keep your destination lists nice and concise. It's better for performance. And look, I know I've said it before, but I can't stress this enough. Get those root certificates deployed before you flip the switch on the policies that need them. You'll save yourself a lot of headaches.
So you've built this beautiful layered set of rules, but how do you know for sure it's going to work the way you want it to? Well, you don't guess. You use the Web Policy Tester. It's super simple. You just plug in an identity, let's say your Office 1 network, and then the destination you want to check. The tester then spits out a crystal clear result. It tells you exactly which rule set and which specific rule it triggered and what the final action was. It completely removes all the guesswork.
And here's the crucial thing. You can absolutely trust the results. This isn't some kind of estimate or a rough simulation. The documentation confirms it. The tester uses the exact same logic engine as your live web policy. So what you see in the test is exactly what's going to happen in the real world.
So there you have it. We've covered the architecture, the key features, the core logic, and a ton of best practices. If you take away just one thing, let it be this. Successful policy is all about 2 principles: top-down evaluation and building specific exceptions. So I'll just leave you with this question to think about. Now that you get the logic, how are you going to structure your rule sets to create that perfect balance between rock-solid security and letting your users actually get their work done? Thanks for watching.